Hello, this is Beth Dixon, and let's do some simplifying expressions. Let's look at this first problem. And in this expression, first of all, notice that it is an expression because it doesn't contain an equals. We have two terms, and the terms are 4x and 3y. In the first term, in this term right here, 4 is the numerical coefficient. Give me just a second to make sure I'm not misspelling it. And if it's misspelled, I'm not going to worry about it because I am not a speller. In the second term, we have 3 as the numerical coefficient of the second term, and we would consider these unlike terms because they do not contain the same variable. In the next example, we have 4ab squared minus 7ab squared. Again, it's an expression. It contains two terms. The first term is 4ab squared. The second term is negative 7ab squared. In the first term, the numerical coefficient is a 4. In the second term, negative 7 is the numerical coefficient. And these would be like terms because the variable parts are identical. A, b to the second, a, b to the second. So if we wanted to add these, we would look at 4 minus 7 ab squared. 4 minus 7 would be a negative 3. The signs are different, so that means we subtract and keep the sign of the larger absolute value, or what I like to call the stronger number, because negative 7 is further away from 0 than 4 is. So that'd be negative 3. And then the variable part stays the same. And then we can just kind of write that out then as negative 3ab squared. Okay, let's look at our next example. Eight x plus 7x, and I'm not going to go into the details about the numerical combinations and numerical coefficients, and coefficients and terms and things. Now we're just going to be doing the combine like terms. oftentimes in these problems, the directions will say simplify. They might say combine like terms and simplify. But that's what your directions are going to say. So in this one, when we combine like terms, the first thing we want to do is see what our like terms are. We have both of these terms have an x, so our answer will be x, and we'll add the number parts. 8 plus 7 would give us 15. Let's look at our next example. 3z minus 4 plus 6z, and we want to add our like terms. In this case, our like terms, and I'm going to just put a box since there's more than one set and kind of terms. I'm going to put a box around the ones that are like, and I'm hoping that I can put and shine that light so that you can see the colors there. And I put a, hopefully you can tell that that's green, so, or at least you can see it's a box. And so those are like terms. And so we have a 3 plus 6. And that's like saying I have 3 of these and 6 of these. So I have a total of what? I have a total of 9 of the z's. Notice that the variable does not change. And then we bring down the minus 4. Okay, let's look at our next example. We have negative 4a minus 2b plus 6a minus 8b. And again, I'm going to go through, and what you want to do is you want to add those things that are alike. Well, I have the a and the a are like terms. And then I also have the negative 2b and the negative 8b, and we'll put triangles around those. And so I want to add those things that are like. Negative 4a and a positive 6a is 2a, because a negative 4 plus 6 is equal to a positive 2. The signs are different, so we subtract and keep the sign of the larger number. Then we have a negative 2 plus a negative 8. Now that's subtract, but that would be the same as adding a negative 8. Negative 2 subtract 8. We can think of that as being negative 4a plus a negative 2. So that's how we get the negative 2 there. However you want to look at it, we end up with 2 negatives, and that would give us a negative 10. If the signs are the same, add and keep the sign. Again, this is my duck theory. If it looks like a duck and quacks like a duck, it is a duck. So we have negative and a negative, so 2 negatives means the signs are the same. We keep the sign, add the numbers, and then the variable part stays the same. Okay, let's flip over to the next page. Let's get a clean sheet. And let's look at another example. We'll switch colors here. And let's look at 3x minus 4y plus 2z minus 4x plus 3y minus 8z. And in this case, we have 3 types of terms. I have a 3x and a negative 4x. I'm going to go on and just add those together. A 3 and a negative 4 make a negative 1x. A negative 4y and a positive 3y make a negative 1y. And notice as you look at these, the sign of a number is in front of the number. It is not behind a number. The 3x is not negative. That negative goes with the 4. The 4y is not positive. It is negative. What's in front of the number determines it. One of our teachers here at Walter State refers to this as a tongue of a wagon, and he's kind of referring to that, hay wagon, where you've got that tongue of the wagon. And where's the tongue of a wagon? It's in front of a wagon. I kind of imagine the little red wagons, and to me that little red wagon has that handle in front of it, and you pull around the little red wagon. So where is the sign of a number? It's in front of it. So that makes this a -4 and a +3. And that's how I get the -1. Okay, and then lastly here we have a +2 and a -8. So that gives me a +2 -8. And when I do that, the signs are different, so I'm going to subtract. 2 from 8 gives me 6, and I keep my sign, which would be negative. And so this is going to then be -6, and I keep my z. And in this case, what we can also remember is we do not actually need the understood 1 there. We could also write this as -x minus y minus 6z. Okay, let's look at another example here. We have 2x minus 4y minus 3 plus 2x plus 4y minus 6. And again, we have various like terms. Now, as I'm doing these for emphasis, I am circling the like terms. Now, you can circle the like terms like I'm going to do here, and what I'm going to do is I'm going to kind of color code and do shapes here to really indicate. I'm doing that for emphasis so that as you're learning this, you can really see which ones are like terms. I put the x's in the same shape and color, the y's in the same shape and color, and the number coefficients that are constants that are numbers by themselves in the same color. You could also rewrite this one where the like terms are next to each other. As you do that, again, remember that tongue of the wagon theory. What's ever in front of the sign is in front of it, must stay with that sign. With that term. In other words, the 4y is not a 4y, it's a -4y. The 3 is not a 3 plus, it's a -3. And the 6 is not a negative, it is a -6. So it keeps that negative sign. And so notice all I've done here is just rewrite them where they're together. So some students like to do it this way. Either way, we get 2 plus 2 then is 4x. Minus 4 and plus 4 gives me 0y. Well, 0 times anything is just 0, so that's 0, and 0 added to anything isn't going to change, so we really don't even need to write this, and this is what we call these are canceling each other out. A -3 and a -6, the signs are the same, so we're going to keep that sign and add the numbers. 3 and 6 are 9, so our answer is 4x minus 9. And that would be our final answer. So that's some problems about simplifying. Be sure that you watch the next video, which will be on simplifying with distributive property, and that will be an important video as well.